Alrighty, so today we're doing ratios and proportions. This is a very fun concept, something that you could actually incorporate in the real life, especially with the next lesson that we're going to do tomorrow. That one is really real world, related. Ratio and proportion. So, let's begin. A ratio, my friends. A ratio, all it does is compare two numbers, okay? So I'm going to try to pull up an example very quick. Hopefully I still have it. If not, we are at a loss. Beautiful. So, here is a word problem. Very short, very small. A softball pitcher strikes out 4 batters for every 1 batter that she walks. What is the ratio of strikeouts to walks? So there is the word right there. What is the ratio? On this first part of the day, this first part of the lecture, we're going to be going over ratios and just, how to write out a ratio. How does a ratio question look on any test that you come across? Well, like that. They'll ask you at the end, what is the ratio? If you are given a question with what is the ratio of something to something, you know all they're asking for is the flat out ratio, the two numbers. Now, what two numbers is it that you're supposed to write? Well, they want to know what is the ratio of strikeouts to walks. So think of it like this. So the question asked us, what is the ratio of strikeouts to walks? What you're going to do is find the number that represents the strikeouts and the number that represents the walks. It's that simple. So when you see this question right here, you have to go back into your word problem. Now in this case, all we have is a sentence before the question, right? It's just one measly little sentence. It's pretty easy to go in and search for the numbers. In more complicated problems, you're obviously going to have a fat paragraph with nonsense, wordish stuff, right? It'll give you the name of the strike of the pitcher. It'll give you the name of the stadium. Just a whole bunch of nonsense. That's just what math likes to do. Just makes your life harder by just giving you nonsense stuff that isn't even related to the problem itself. All you care for is if they ask you what is the ratio, and if so, go hunt down what it is that they want you to find. So in this case, we go back into the word problem, and we go look for the strikeouts, and we go look for the walks. A softball pitcher strikes out 4 batters. There it is, strikes out 4 batters. 4. So guess what? The strikeouts is 4. 2. How many walks are there?
1.
Strikes out 4 batters for every 4 batters for every 1 batter that she walks. So the walks is 1. If that's pretty straightforward, guess what? That's all ratios really are. Your final answer is 4-1. That is your final answer. It could look like that, 4-1. Or there's 2 other ways that you could write it out. It being 4-1, which is the same thing, just with the colon, which is probably how you're mostly going to see ratios presented. When you see that colon, that means you're dealing with ratios. When they ask for the ratio, chances are you're going to want to write it like that. Not that the first part is wrong, 4-2-1. But that's the colon is the one that you're going to see most likely. And then we have the stuff that we worked on last week. It could be written as, oh man. It could be written as a full-blown fraction. 4 over 1 is the same as saying 4 to 1. All right? These are the 3 ways to write out your ratio. Either 3 ways that you do on the quiz or on your worksheets, it's 100% correct. As long as you present it as a ratio. I'll tell you what isn't correct though. What is incorrect is when they ask for what is the ratio for strikeouts to walks, and you end up giving me 1 to 4, or 1 over 4, or 1 to 4. That is incorrect. That is a completely different ratio. If the question asks, what is the ratio of strikeouts to walks, you have to write it out as strikeouts to walks. If the question were to ask, what is the ratio of walks to strikeouts, then this would have been correct. It's that straightforward. Does that make sense, folks? So how about we turn it up a notch? How is ratios gonna kind of, sneak attack us? There's 2 different ways you might get the incorrect answer of a ratio problem. Well, 3 if you include this one, if you accidentally flip what they're asking you to find. But the other 2 ways is like this one. Frank manages a small drugstore. During a 2-hour period, he counts 25 cash sales and 15 credit card sales. What is the ratio of credit card to cash sales? If you notice, they kind of started to add those irrelevant things that I told you math word problems love to do. They started to mention the manager's name, Frank. I could care less about what his name is. Manages a small drugstore. It's nonsense. I don't care what they manage or whatever. What I just care for is the relevant things, which is the question and the detail section where I could find the numbers. That's all you're really looking for in a word problem. But they're starting to slowly creep up with the nonsense stuff, so just watch out for that. But what is the question asking for? What is the ratio of credit card to cash sales? If it helps, always write it out. Always write it out. Credit card in whatever way you want to write your ratio. In this case, I'll go with a fraction. Again, you could have done credit card to cash sales. You could have done credit card colon cash sales, or in this case, credit card over cash sales, which is the same. They're all ratios. But if it helps, you could always write out that. You could always write out what they're asking for in the format that you're going to lay out your ratio. And all you have to do now is go and hunt down for those numbers. What was the credit card sales that Frank had?
15 credit card sales.
Good, so you didn't fall for the trick. 15. A lot of people always think the first number just happens to go for the first thing, right? And that's not the case. You have to always pay attention to these word problems. So 15 credit card sales. How do we know it's 15? Again, because we have to go back and read. And we see right here, 15 credit card sales. So it's 15. Over how many cash sales? Come on, folks. 25. Okay, boom, you have your ratio, 15 over 25. If you put that answer down, you are incorrect. The reason why is because guess what? It's not in its simplest terms. So just like last week, Your fractions, I'm going to be strict this week. It must be in simplified, in its lowest terms, simplified terms. So 15 over 25, what does that reduce to? 3 over 5. So guess what the ratio is? 3 to 5. 3 to 5. 3 to 5. Any of these numbers, the way you present it is correct. You decide which way you want to do it. But it has to be definitely like that, in that order, not 5 to 3. It has to be like this, in simplified terms. Yeah?
What was it, the 15 was like a 13 instead of a 15?
Could 13 over 25 be simplified? That's your ratio, 13 to 25.
No, 14.
14.
That'd be a 7, right?
14 can be divisible by 2, but 25 is not divisible by 2, right?
Right.
Do they have any numbers that they're both divisible by? No, so guess what? That's 14 is another number where it just can't be simplified.
Okay.
All right, so here we have another one. A football team won 12 games and lost 8. There were no tied games. What is the ratio of games won to games played? So, my friends, guess what? This is an example, another example of how you might come across a tricky ratio question. A football team won 12 games, blah, 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 whatever. Always go to the question, what is the ratio of games won to games played? So we want to look for games won to games played. I want to write it out like that, as a ratio. So tell me, how many games did they win?
12.
Tell me, how many games did they lose?
8.
Oh, y'all fell for the trick. So this is what I was saying. I did hear a 20 out there. My friends, it is 20. Always ask yourself, what is the ratio question asking you? They are looking for games won. Were we given games won? Yes, right here. A football team won 12 games. But they want to know games won to games played. Did they give us how many games they played? Well, you could find it, but they sure as heck didn't give it to us in plain letters, right? They didn't give it to us in the word problem. They gave us instead games lost. So again, welcome to math word problems. Welcome to tricky word problems, right? So they gave you the games won, games lost. They want to know how many games they won to games played. What is needed to do? My friends, just a very, very small and quick addition problem. If you know they won 12 games, and you know they lost 8, all you got to do is add to come up with 20, and that's, guess what? The total games played. And the only way you would have ever come up with that is by actually reading what they're asking for. Games won to games played. This is going to test how well you are with your analyzing skills. Yeah, you're just gonna see how well you are with, sure, your math in general, like your additioning or subtracting sometimes, how well you are with your simplifying of fractions. But the main thing of ratios is how well you could analyze the word problem and not get tricked, right? So 12 to 20. Are we done?
3/5.
What about simplified?
Exactly. We are not done. We have to simplify. What is 12/20 simplified down to be?
4 and 5? Oh, sorry,
3/5. Yeah, so like I said, this is going to test your analyzing skills to see whether you actually find the correct numbers. And the same thing like last week, how well you simplify. So 3/5, again, I don't need to write it, but just in case, so I could have it burned to your brain. It could be 3/5 under your multiple choice problems, or 3 to 5. Either, any of those options are fine as your final answer. Any questions on ratio? So we just saw how simple it could be and the 3 ways that you could write it out. We just saw, all right, keep track of your simplifying. Always simplify your fraction or ratio. And how sometimes ratio problems might require an extra operation before you write out your answers. Okay. No questions on ratio? If that's the case, we're going to move on to proportions now. Ratio and proportions are both the same, not the same, but ratios, as simplistic as it just was right now, that simplicity is going to be applied to proportion problems. Proportion problems. What are proportion problems? I love this lesson here because I get to draw this right here. I get to draw my famous two cars. That one looks a little different than the one back there. There it goes. Okay, here I have 2 cars, all right? This is a traditional proportion problem. You've probably seen a proportion problem in almost any tests you guys have come across in this country of ours, whether it was the WASL, WALMAP, CASAS to enter this, GED, whatever the case, you saw a proportion problem. So here we have this right here. In case this comes out to a decimal. Oh wow. Get your calculators ready if possible. In case this comes out as a decimal. That way we could bypass doing it by hand and not waste too much time. So here I have a diagram with some measurements, and now comes the word problem, which I'm just going to say it, so pay attention. A designer is creating a miniature clay model of next year's Lamborghini. He or she comes up with this diagram right here, this clay model for the 2019 Lamborghini, which measures 4 inches and 3 inches. So just imagine how small it is, right? Gets the design and everything perfect, gets the clay model, presents it to his company, his or her company, and they give him the okay to design the actual car. So the company builds the car and it comes out to be 5 feet high. And the question is, how long is the actual car? If the proportions are the same. So that's a traditional proportion problem right there that I just said. How do you solve it? Well, you solve it by doing just a very quick little math structure. What you have to do first is something called the setup. You have to do your setup first. Here, this is what I mean. In a traditional proportion problem, you will be given one ratio. In this case, the first ratio that they gave you, they just handed to you. It was a freebie. They gave us 3 to 4. 3 to 4. Can y'all tell me, what did that 3 represent? And no, I don't mean measurements. I don't mean inches. I mean, what did the 3 represent?
The height.
The height, right? So guess what? The top part is the height. What was the bottom part? The 4.
Length.
The length of the little clay model, right? So they're always going to give you a freebie, something to something. In this case, 3 to 4 was the one that they gave us. What you do is you write out that ratio, in this case 3 to 4. You then put equals, and across from it you put the second ratio. The trick is, one of the numbers from the second ratio is missing, obviously, right? Which one is missing on the second ratio? Was it the height or was it the length? The length. So guess what? The length is the one with the missing number, which is x, which is the one we're going to look for. But the height we were given, it was 5, right? The last thing you want to do is to accidentally, this right here is how you will always get the wrong answer if you do your setup incorrectly. If you accidentally put the 5 below and the missing number up top. Because we are going to do a little math here, and if you do your setup incorrectly, the math that we're about to do is going to come out incorrect. So make sure you always have it correctly. There's a reason why I labeled this here. Is because the numerator part should all be matching. It should all be heights. And the one below should all be lengths. Sounds simple, and you're probably wondering why I'm just like not moving on. Is because I notice every single quarter is the same thing. People always get their setup, wrong. And that's the last thing you want to do, trust me. So you got your setup, right? You got the 3 and the 4, you got the 5 over the x. Okay, boom. What's this math part, Neil, that you were talking about? What must I do to solve for x now? Well, we did this last week, kind of, but it's not going to really help us here. You could have taken the route that we did last week, which is ask yourself, 3 times what number creates 5? And if you find that number, which is a decimal, multiply the bottom one by that same number, and you'll find the missing number, right? But that's a lot of decimals that we don't want to do by hand. There's a cool little trick, which is this right here. Look for, my friends, your numbers that are diagonally from each other. So what I mean by that is 3 and x. No, that's incorrect because one is an x, the other one is a number. That's not what you're looking for. You're looking for 4 and 5. Those are the two numbers diagonal from each other. What you're going to do with those two diagonals is multiply. What's 4 times 5?
20.
Okay, so 4 times 5, 5 times 4, whatever, is 20, right? So you're always going to look for a diagonal and multiply it. You are then going to get that answer that you just got and divide it by your third number, which is in this case 3. So we cross multiply, then divide by your third number. 20 divided by 3 is what? 6.6. I'll trust you. So, guess what the missing number is? 6.6, which means the length is 6.6 feet. Which makes sense visually. 3 to 4, 5 to 6.6. You know, if your number here came out to less than 5, you know you have it incorrect. Can somebody tell me why though? Let's say we did a cross multiplication, divided by the third number, and out of nowhere this length that you got came out to 4.8. Sure, it might have been that you made a small mistake under your calculations or whatever, right? But how would you be able to spot right away that you were incorrect? Because 5 is the length of the height, right? Well, if we look at our smaller proportion here, 3 was the height. The length was larger than the height. So by default, when you blow this little clay model up, it's only logical that the length should be larger than the height. Makes logical sense. So watch out when you do your math and you come out by accident with something that looks weird. And it doesn't just have to be smaller. What if we came up with a number here that was like 50 feet by 5 feet? That's a little too much, right? It's actually a lot. So when you get really small numbers or really large numbers, you should be aware that it just doesn't make logic. There has to be a question here. Any questions? I will do another example. They won't always give you a diagram, but I like drawing, so I'm going to always draw something. This is just to pass the time is all. Can somebody tell me what this is? Nobody?
Basket?
It's a basket. Can somebody tell me what's in it?
Vegetables?
Yep.
What's in it?
Let's go with 6. Okay. So this is a fruit basket with the first ratio. Again, they don't always have to give you a diagram or a picture or anything. This could be said in straight up word problems. So you guys have to read, right? But it's all the same thing. If it helps, draw it out. One fruit basket has, for every 3 tomatoes, it has 4 bananas. So for every 3 tomatoes, it has 4 bananas. Tell me, how many bananas are there in a fruit basket that happens to have 6 tomatoes? So do your setup. Do your setup always. Our setup is going to look like this. Well, I know my first ratio, it was 3 to 4. No, it was 3 to 5. Did I say 4 bananas? I meant to say 5. Because I drew 5 bananas. My apologies. So there's 3 to 5. 3 to 5 is the first ratio. Equals, where should my tomatoes go? I said there were 6 tomatoes. Should it be your numerator or denominator? So I put the 6 up there because the top row is designated for tomatoes and tomatoes only. Now, what about the bananas? How many bananas are there? Well, you do 5 times 6. What's 5 times 6?
30.
You then divide it by the third number. In this case, another 3. Wow, let's have a habit of putting 3s down. So, what's 30 divided by 3?
10.
So, there has to be 10 bananas in the fruit basket. That, my friends, is how you solve proportions. So, the question is, how many bananas are there, right? Which means the answer is 10. Or in the case before, 6.6, right? In these problems, you're literally just solving for the answer. There is no simplifying of this fraction or that fraction or whatever this, whatever that. You are just finding me for the missing elements. You are solving for x. We're not to the point of what we're going to be doing later on in the quarter with algebra. We're going to be solving for x, y, all that jazz. So be prepared for that. It's going to be a fun week. But this is still solving for x in some ways. All I want is my final answer, which should just be one number. Alrighty, my friends. I don't know about y'all, but that was one heck of a lecture. Any questions before I hand out the worksheets, and then y'all could get started? Question? Yes.
It's not, I mean, it's about the lesson, but do you mind simplifying for me? I missed that.